So now what do we do since we've done the structure free body diagram? We had 4 unknowns and we only need to find 2 of them. We need more equations. The thing to remember is the structure itself being in static equilibrium, each component must satisfy the needs for static equilibrium. If we bust the structure up and start taking a look at each individual piece, if the structure is in static equilibrium, each individual piece must also be in static equilibrium. So that means each individual piece is going to have to be, some of the forces in the X, Y, and Z, some of the moments, all have to be 0, because the overall structure is, so each of these individual ones are. So let's go and take a look at it. There's our overall structure. And so this is our free body diagram. And remember the last equation, we do have that last equation from the structure that told us that AY plus CY has to equal 30 kilonewtons. So this is the equation. We're going to come back to this equation, but we need more information. So now what I want to do is I want to take a look at just AB. So now let's pull out AB. It's pinned at both ends, and I am going to use red for the external forces, AX, AY, and then 30 kilonewtons. Now actually, as we break this up, BX and BY is going to be this internal pin, but there's still technically an external force to this linkage. And so since we have B, it's an internal pin joint, well that tells us that we're going to have a BY and a BX. So now that we have this free body diagram of this component, what we can do is we can start applying our equilibrium equations again. Now we're looking at this, we have AX, AY, BX, BY, so now we have 4 unknowns. We already know AX, we've got 3 unknowns. Now the problem is, we could solve BX and BY right now, but remember, we're trying to find what AY is. So the better play would be to, if we can, solve this without having to worry about what's going on at B, because I just want to figure out what AY is. So if I sum my moments about point B, BX, BY, and the 30 kilonewtons all fall out. In fact, we'll do the sum of the moments about point B, counterclockwise is positive, equals 0. If I look at my lines of action, AX, BY, BX, and 30 kilonewtons are all at B, so they're all going to fall out of the equation. AX is also right along that line. So what we're going to have is we're going to have AY times 0.8, and that is going in the clockwise direction, so it's moving this way, so it's negative, but that's got to equal 0. So this tells me that AY has to equal 0. Now what I can do is I can take this AY, plug it back into this other equation, because even though it is the structure, it is still, AY is AY, and so by doing that, that's going to tell me that CY has to be 30 kilonewtons. So, what are our results at this point? Well, we have that A is 40 kilonewtons. Sorry, A. Just A in general is 40 kilonewtons because there is no AY. So you can say it's AX, but it would just be the force at A. And because when we solved it, it's positive, that's telling me it's going in that direction. We solved for CX, and CX was also 40 kilonewtons. But if we look at our initial solving from the last video, it's in the negative direction. So we drew it incorrectly, so it's acting to the left. And then we just did CY, and so CY is going to be 30 kilonewtons, and that is listed in as a positive, so we picked the right direction, so that is straight up. So there are our 3 reaction forces that we have on the structure. And so these forces here, these are our reaction forces on the structure. Okay, now that we have all the reactions, we are going to move on to finding the forces in the members. And this is what's going to be important, because once we know the forces of the members, that's what's going to give us the internal forces that we really need to solve for stresses. And we will do that in the next video.